Let's have a look at example 7 together. Now this covers a lot. It says Marcelo is playing in a cricket match and a game of hockey at the weekend. The probability that his team will win the cricket match is 0.2, and the probability of winning the hockey match is 0.6. Assume that the results in the matches are independent. Now this tells us a lot. On the previous page, this is the information from the previous page, you may not be able to read it here, but you can check in your book. The previous page to example 7, it talks about, it gives formulas for independent events. Okay. It also gives information about the intersection down here and also union. Okay. So we've got a lot of formulas here. It talks also about mutually exclusive, which is covered in C here. Now there are no diagrams in the example in the book, so I've written 2 diagrams because you could do it with a Venn diagram or a tree diagram, or you could just use the formulas. Now the book just uses the formulas, but the formulas are clearer from the Venn diagram than they are from the tree in some instances. So let's have a look at A. Well, before we look at A, let's go back here. It says the probability this team will win the cricket match is 0.2 and the probability of winning the hockey match is 0.6. So this is only the winning events here, winning the cricket match and winning the hockey match. Okay, so we could write that in. Let's just write that this one here is the cricket match and this one is the hockey match. Okay. Now what they're saying is here, it says, find the probability that Marcelo's team wins both matches. Okay, if they win both matches, it's got to be within this area here. Okay, that would be winning both matches. That area is winning both matches. Now, how do you find that area? Now, that area for an independent event, if you have a look over, remember this on the previous page, independent event here, okay, you can see that the intersection is just the probability of one times the probability of the other for an independent event. Okay, so let's have a look at that. So we've got the probability. So we've got the probability of that intersection, which is the probability of C intersection H, equals the probability of C times the probability of H. Now they told us the probability of C, all right, they told us that, it's up here. Probability of a cricket match is 0.2, that's winning a cricket match, and winning a hockey match is 0.6. So that's 0.2 times 0.6. Now that's 0.12. That's the probability. Now let's have a look at it on the tree diagram. Now let's say that this region here, is the first game on the weekend, which in our case is the cricket match. Okay. And this region here is the hockey match. Okay. Okay. So let's represent this on a tree diagram. We were told that for winning a cricket match was 0.2, so we can write 0.2 there. Well, if winning is a 0.2, then losing is going to be a 0.8. Okay, for the cricket match. Now for the hockey match, winning is a 0.6. So we can write 0.6 here. That's for the hockey match, winning. If it's winning is 0.6, then losing is 0.4. Now similarly here, winning is 0.6, losing is 0.4. Okay. Now what it says is, it says find whether the Marcelo team wins both matches. Well, to win both matches, that would be here. That's a winning both matches. And remember, in a Venn diagram, in a tree diagram, you multiply along the branches. So that means probability of winning both matches equals 0.2 times 0.6. that equals 0.12. Well, that's the same. Okay, so there's got the same answer. There we got the same answer, right? We're using the formula. We can see it in the Venn diagram, and you can see it on the tree. Okay, so that's A. Now let's have a look at B. B says find the probability that Marcelo's team wins the cricket match or the hockey match. Well, to win the cricket match or the hockey match, if we go to the previous page, that's the union. That's either the cricket match or the hockey match, or both. So that's that one. So it's the union there. So we can highlight that. That would be this one. Okay, so if we use the Venn diagram, okay, I'll just use this spot up here. We're now saying that the probability of the union of the cricket match and the hockey match equals the probability of the cricket match plus the probability of the hockey match minus the probability of the intersection of the cricket match and the hockey match. Well, that would be probability of the cricket match winning is 0.2. The probability of the hockey match winning is 0.6. And as we saw, the intersection is 0.12, right, because we had that here, 0.12. So the probability of the union of the cricket and the hockey match is going to be 0.8 minus 0.12, and that's 0.68. Okay. Now there's another way to do this, which I think might remind you a little more of how you've studied Venn diagrams in the past. Let's have a look. If we already knew that the intersection was 0.12, we can directly write that here as 0.12. Now if we write that as 0.12, what's left? Well, the hockey must be 0.6 minus 0.12. So this area, because the whole circle of H has to equal 0.6, so 0.6 minus 0.12 is 0.48. Similarly, with the cricket, it said it was 0.2. Well, that's 0.2 in everything. We've already got 0.12, so this must be 0.08. And when you add up all of those, you just add them straight across. That's all you need to do. 0.8 plus 0.12 plus 0.48 is equal to 0.68. You can just add directly across that way. So that is another method to get 0.68. Once you know that, and you already know the probability of C and the probability of H, you can then work it out across that way, or you can use that formula. Now, how does it work for the tree? For the tree down here, can we do B using the tree? Okay, well we can, because it says find the probability that Marcelo's team wins the cricket match or the hockey match. So it's everything but that. We can't include that. Okay, we can't include that because that's both losing. But what we can include is this line, because he's winning the cricket and losing the hockey, or he loses the cricket and wins the hockey. It was only the probability that he wins the cricket match or the hockey match, or both. Okay, so including that as well, actually. So it's this one, and that one. Let's add all those up. Okay, so that would be the probability of winning the cricket match or the hockey match equals the probability 0.2 times 0.6. That's that line. Okay, that's winning both, which represents there. That's the same thing, right? Plus, now the reason we add this is because you multiply along the branches, but you add down. So the result from each branch you add together. So now we're going to multiply these together. That's 0.2 times 0.4, and we put the number here, right? We're going to add down. We've already got 0.12. 0.2 by 0.4, okay, is 0.08. So we've got to add that. it's plus 0.2 times 0.4 plus, we've now got to add this one, 0.8 times 0.6. We add that one. Okay. And that is 0.8 times 0.6. Well, that is equal to 0.12 plus 0.08 plus 0.48. And altogether, those also equal 0.68. Okay, so that's another way to do it. Now the last part here, C, determine if winning the cricket match and winning the hockey match are mutually exclusive. We just have to go back to the previous page where they talk about mutually exclusive. It says they are mutually exclusive if they cannot both occur. Okay, well these can both occur, so they're not mutually exclusive. Follow up this by looking at what the textbook says for this example and have a look through there. If you've got any questions, let me know. Okay. Well done.